Redstone Wiring. Today we're going to talk about wiring as it applies to Minecraft. If we're building circuit and logic, it's a little bit different than it is. Here we are at our world we created last time, standing at the door, and we're going to want to walk our way this way and head to an area about right back here. If you've done a lot of redstone, you may have noticed there's several things. One of the first things is if you lay redstone by itself, it automatically connects. If you do that one higher, which is here, and I'll extend these wires over. So even though one up, it still connects. You can see it comes down the side. If we choose to go one down, we run into the same thing. This can be a problem. We have to find a way to get wires close. Now you can always keep wires separated by a space, like this. You may choose to do that, but as they get wider and wider and you build bigger and bigger components, they take up a lot of space. But that is probably the safest way to do it. There are other methods though. One of the things that you can do is go down two spaces. So lay some wire out along here, and then right by it, we're going down two. Just like this. Now down two. You can see that it doesn't connect. So we can actually use this by placing a block here. You could bring in a connection from somewhere else and not worry about it connecting. And the way that is done is you either extend this further, such as this, or you bring it in from the side, such as this. So that's the closest way you can get wiring. Now there is one way you can get a lot of wiring connected together, and this is kind of called a conduit. I'll lay some wire out here, put a block up here, right alongside it. This would be our next wire would go. And we'll put wire on top of that. Of course it will connect. Just like this. Now, the way to avoid that is I'm going to put a block on top of here, like this, and then you can just click right on top of all of these and get this in place like so. Now you can see that is disconnected the wire from the side. So now you have a couple sets of wires here. There's this one, and there's this one. They're not connected even though they are side by side. I could go down here again with the wire. Once again, it connects on the side, but I can do the same thing here. Put a block up, and the block disconnects it. Of course, if you want to keep wiring in small space, you do the same thing here. I'm going to lay out some wire this way. Do the same thing on the other side. And then, of course, you know where to put the block? Right here. So this is a way you can create a lot of wiring in just a little bit of space. So you see we have actually 1, 2, 3, 4, 5, and of course I could put another one on top if I wanted 6 in the blockhead. So I consider this called putting a block. The problem with something like this is it's good for maybe running wire a long distance, but as soon as you want to bring this one out, how are you going to do that? It connects. So you actually have to go down here and this way. And you bring it right back to, it doesn't actually have to be down for this one. But that way you can avoid the connection. You need to come down, you can keep it flush if you want. But let's go ahead and do this. Now bringing these down becomes more of a challenge. You can't bring them down here, because as soon as we lay wire here, you get that connection. So they actually have to space out even further, like this. And you're back to the situation where you have wires, unless this one is running off this way, and 2 down method right here, you're kind of back to where you were. So while conduits can be useful for putting a lot of wires if you have a long distance to go, they're not actually easy to wire out of. And of course, as soon as you do anything in here, if I cut this, I immediately get the connection. So they have to stay in this shape. So that's really not advised that much. We'll talk about probably the best way to do this in the future. But one problem you get into with redstone wiring is a loop. So I'm laying a little bit of wire here. We'll just go right here. I'm going to put a repeater here. I'm going to bring this over to here and put a lever right here. So now we have just a circuit that's going to go this way. When I turn this on, everything lights up. No problem, it all looks good. Maybe you've got some sort of mechanism that you're powering in a couple of these places, like so. When I come back here and turn this off, what happened? It stays on, and the reason why is the power comes out here at 15, as we can see. It goes all the way to here. When it reaches here, it's at 7, 6, 5, 4, 3, back into this, and the repeater repowers. So even though we no longer have a power source, our circuit stays lit. Of course, as soon as I break this anywhere and put the wire back, it's off. I put any sort of powering device, take it away, it stays lit. This is a loop, and this is what you have to be careful for. You have to avoid these, especially in circuits, because circuits will have a certain state that you want to maintain, and if you end up with a loop in it, it can change that state. Even after you fix the loop, it can be in the wrong shape. Using this sort of blockers is kind of used where you can create a lot of wire and create these on the edge to keep them from connecting. But you always want to avoid the loops to avoid the constant power problems. One little trick you may have when you're doing some redstone wiring is able to actually divert connections. I'll show that here. Suppose I need to wire a mechanism back here. Like so. But I don't want this actually pointing into this. If I turn this circuit on here, I don't want this light to come on. There may be some other device here. Maybe I've got a piston or something like that here. So I don't want this connection. What you can do is put a block here, and any sort of device it can connect to, like this, there. And you see that diverts the connection from going forward into that block into here. And so now maybe you were going to go ahead and power the piston like so. And now you have control over the piston, but you didn't connect to that line. Take this away, it'll connect back into that. As soon as you replace that, it connects back. So this is using a power source or some other mechanism that can fire. In this case, the switch, it doesn't matter. It doesn't actually do anything. So if I were to choose a piston here, then it would fire and we would have an issue with that. So this switch there allows you to divert the wire and not have it connect. So a lot of times when you're working in a tight space or a small space and you want to power some device on this side but not this one, this is how you can actually divert that wire and make sure it doesn't happen. Okay. Now of course if you have, I'm just going to use this color to make sure that we have this. I'll even put a mechanism such as a light here. And I'll put a few more. You can redstone wire right up by a mechanism. You see that does not turn into that light. So this could be several different things. Let me put a piston here. Same thing happens, you see it doesn't connect. So you're okay in wiring along. The disadvantage of that is if I really did want to power that, I would have to do it like this. So you have to come from one away into any block. It's the same thing if I have just a simple block like this. Put down a power source, I'll just put down a torch. So now this is powered because block is powered. We talked about how I can pull power from a weakly powered block like this. Once again, there's a demonstration of that. This will not be powered because this is weakly powered. I can put a repeater down. I can put it there. That is how you have to connect one away from a block. If you want it to go in a device, you have to stay one away to get it to point into the device. You'll see on this side, where I went right by them, there is no connection. Same thing with this repeater. It's a little different. When I come to here, I'll get the connection of the wire. But the same goes for any sort of repeater. I can wire by it. It won't connect unless you saw my wire terminates and connection in the other direction. So I always have to have one away if I want it connected. But I am allowed to run wire right by it. So if for some reason I had a space like this and a repeater there, I could do that. But once again, connecting this in, even if I'm two down, I end up connecting them all. And there's no way to put a guard here like we did before. If you put a block up here, you can't do that. So usually you end up finding that this is a connection that doesn't make any sense anyway, but it can be useful for certain situations where you might have a repeater going to a circuit and you're wiring something along these lines. Maybe you were coming here. This wouldn't be here in this case. It might be on that side and you're wiring. So you can do that. That's okay. Alright, we'll go back over here. You also have what are called bridges and tunnels. If you want to bypass a switch, I'll go ahead and power this one. I'm going to run this wire out a little bit. Or do the same thing here. And so I have a mechanism here that I want to power from this line over here. I can't just run it over because I've now powered this line too. So let's say we have a light there. They want to power from that line. Well, in this case, let's say my connection was there. Now you see I have the problem that I'm powering this one because it's powering up this line over here, and this can power both sides of this wire. So what you need to do is you build this bridge. Remember, it was originally back here. I come up, 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 and now I can go on top. Now I can power these two lights off independently. I'll put switches here. One. That's one way. Of course, I can do it again by going under. So here, it's a little harder. I have to tunnel that one. Here. And this is the difference with tunnels. I have to get my power to each one. So unlike a bridge, which can be 3, a tunnel, you see, requires more. But I can just do this. In that case, over here, the best I can do is this. So you kind of have a minimum distance for a tunnel. It is 1, 2. I can't bring it up here, and the reason why is if I put a block here, you see that I cut off that wire. So this is kind of the minimum for a tunnel. And then I would need to either, if I wanted that situation, if I wanted this right here, you would think I could put a repeater here, but you can't. Because you can't power a repeater from below. Alright, let me go turn this switch on and you'll see. Alright, it doesn't make it up to here. Fortunately, you don't have to. This is going to weakly power this block. You see? So you're okay. If you wanted that strongly powered for some reason, you wanted to pull more off the backside of this, you would have to put a repeater in place here. can't do that. This is normally how you do it, but you can't do that because you can't power it from down here. Okay, so in that case, the minimum that you're able to do is something like this. The repeater goes here. And now this block that's underneath here is strongly powered. I'm pulling the power out of that block to reach whatever mechanisms I wanted over here. This is a bridge, and this is the tunnel. That's it for this episode of Math Minecraft to Computers. Hope you enjoyed the Intermediate 2 I2 episode. Bye-bye.